Hello there, very welcome. As you can see on your screen, we have got this circuit that consists of a resistor. It also consists of a capacitor. Here you have an input signal V in, and here you have an output signal V out. So you can say that we have voltage in and we have voltage out. Voltage out is taken across the capacitors. The values of R and C will determine the cutoff frequency of this circuit. So quantitatively we can analyze the circuit. For example, if your input signal has a certain amplitude, peak amplitude or peak to peak amplitude, and it has got the frequency, let's say f. If that frequency is very less than the cutoff frequency of this circuit, which is fc, and fc can be written as 1 over r times c. So as I said, the cutoff frequency is decided by the values of the passives R and C. So if we focus on this point, F is very less than FC, then the impedance or reactance of this capacitor is very high, because impedance is inversely proportional to the value of capacitance and the frequency. So if the impedance offered by this capacitor is extremely high, this capacitor acts as an open circuit. That means your signal V in gets connected or gets transferred at the output, appears at the output directly. There is no rejection of the input signal. On the other hand, if you say the cutoff frequency f is very greater than fc, very greater than fc, that means your impedance of the capacitor is extremely small, ideally zero, making the capacitor acts as a short circuit. So in that case, your output voltage across a short circuit is equal to 0. So from this we can understand the behavior of the circuit as a first order low pass filter, where the frequency response can be plotted like this. You have the gain of the circuit, which is the ratio of output voltage divided by the input voltage. Here is output voltage, here is input voltage, and ratio of the two, V out over V in, is your gain, and here is your frequency. So initially from DC up to certain frequency, you have a constant gain of unity, because you don't have an active element to provide the gain. As I said, the V out is equal to V in. Okay, that's why the gain of the circuit is unity or 1. And at a very high frequency, your gain drops to 0, and the drop rate is the slope of this line, which is minus 20 dB per decade. And you can see that this frequency response is LPF, that stands for low pass filter. So this is how the circuit will behave as a first order RC passive low pass filter. Okay, let me give you an exercise here. Swap the position of resistor and the capacitor in the circuit, and once you do that, then analyze the circuit frequency response, what kind of filtering action it will provide. So put your answer in the comment sections and provide your opinion. Hope you found this model useful. If you did so, share it with others for a wider reach. Till then, wish you happy learning.